Hello everybody, this is the numerical wizard. Welcome to my very first video of this channel. There's still more to come. Make sure you like and subscribe to my channel, and yeah, let's see what we have here. This question was written in Limpopo for the preliminary exams. You were supposed to prove the identity, prove that left hand side is equals to right hand side, or the right hand side equals to the left hand side, whichever way you want, right? So in this instance, right, my advice to you guys is that you choose the side which looks the hardest, right? When I say the hardest, what do I mean? I mean that you choose the side which is looking a bit more difficult, right? Which looks more complicated, right? Which looks more complicated, right? So that means that this side, right, which I just circled, is the one you're supposed to use to get to the right hand side. So that means we're choosing the left hand side, right? So since it is a ratio, right, over another ratio, or let's just say a fraction over another fraction, right, we find the LCD first, right? Whenever you find, let's say maybe it's 1 over 2 minus 3 over 2, right, the first thing you do, right, is you cross multiply, right? This multiplies that, this multiplies that, and the denominators multiply each other, right? So that means you're going to have what? 1 times 2 minus 3 times 2, right? All over 2 times 2. This is how it works, right? All the time, right? So with that principle, that same principle, we're going to use it on this question, right? So what do we do here? We cross multiply. So sine multiplies 234, cos 36 multiplies everything there, right? So that means we're going to have what? Sine 234 degrees. 234, sorry, right? But yeah, basically it's what? Sine 234, right, degrees multiplied by what? Sine x, right? Multiplied by sine x, right? Subtracting, right, with what? Cos 36 degrees, right? Sine x minus 90 degrees, right? Cos of 90 minus 2x, right? All over what? The denominators multiply each other, right? So that means what? You'll have cos 36 degrees multiplied by what? Sine x, right? This is how it works, right? So now it's in a standard format, right? So as we move forward, what do? We try our best to fight against these big angles, right? You see 234, it's too big, right? It's not easy to work on it. We should fight by all means to reduce it to maybe an angle which is this small, like 36, right? So what do? We say sine, right, 234, right? We can use 360 minus, or 180 minus, or 90 plus, right? Or 180 minus, the same thing, right? But what I'm choosing here is 180, right? So 180 plus a specific number gives you 234, right? So what's that number? It's 54, right? That's the number. It's 54, right? So that means as we move forward, right, we write what? Sine x subtracted by what? Cos 36 degrees, right? Sine x. Whenever we have a negative angle, my way is that you add that angle by 360, right, until it is positive, right? So it's negative 90 plus 360 times cos 90 minus 2x, right? 90 changes to sine. When we have a 90, right, it tells us that it can change to either sine or cos, right? So if it's cos 90 minus x or 90 minus 2x, it changes to what? Sine 2x, right? The 90 just basically tells you that you're supposed to change your trig ratio to another format. So if it's cos, it's sine. If it's sine, it's cos, right? The ones below, which is cos 36 degrees multiplied by sine x, do not change, right? We leave it exactly as it is, right? Sine 180 plus 54, right? 180 plus is in the third quadrant, and in the third quadrant we know that sine is negative, so we write sine what? 54 degrees multiplied by what? Sine x, right? Subtracted by what? Cos 36 degrees, right? Multiplied by what? Negative 90 plus 360 is what? 270, right? So we are left with what? 270 degrees plus x multiplied by what? Sine 2x, right? Sine 2x is a double angle of a sine, right? We know how it changes, but there is, you might ask yourself, why am I not changing it? Because we still have complicated stuff. Mina, I like to change things at the end, right? I change things which are changeable, like the big angles and whatever, but when we have double angles, right, I suggest you change them at the end where you see equity, you can't move forward, right? So cos 36 times sine x is still the same thing. Cos 36 degrees multiplied by what? Sine x. So now let's rub here at the top because I don't no longer have much space, right? So this is what we do as we move forward, right? Don't forget, our main goal is to end up finding what? Cos 2x, right? So let's continue. Negative, if you check, we are having this, right? So as we continue, right? As we continue, we check that, wait, we have sine 54, right? And then 54 is the same as what? 90 degrees, right? Minus 36, right? We can write this, right? So that means 54 and 36 are reducing angles. That means you can change sine 54 to cos 36, or cos 36 to sine 54, right? Or you could say they are complementary to each other. They complement each other. You feel me? So it's sine x, right? Negative, right? Cos 36, right? Why am I stressing so much on changing sine 54 to 36? Because I see that in terms of the angles we have, there's 36, 36. So 54 can be changed to 36, right? If it's changeable, change it, right? But I could have changed 36 and 36 to 54, but that would be too long because I have two angles and it will take too much time. So it's better to change the only one you have, right? So we check sine 270 plus x. 270 is the same as 90. Yeah, when you see 90 or when you see 270, just know that your sine ratios change, right? So here in sine 270, right, it changes to negative cos x, right? And if you're struggling, like I said, wherever there's an x, just put a 1 there and punch your calculate. If the answer comes in negative, that means your answer should be negative cos of that x, right? So you say what? Negative cos x, right? Multiplied by what? Now, your double angle of sine, right, can be used now. We can change it. So we change it to 2 sine x, right, cos x, right? All over what? All over the same cos 36 times sine x, right? So we write it cos 36 degrees times sine x, right? So sine 90 minus, I told you, whenever we see a 90, we know that our ratio changes to another thing. So if it's sine, changes to cos. If it's cos, changes to sine. So sine 90 minus 36 gives us cos 36, right? So write negative cos 36. Why did I write a negative? Because it already had a negative in its original equation, right? Multiplied by what? Sine x minus negative cos 36 times negative cos x gives you what? Positive cos 36, right? Because negative times a negative gives you a positive, right? Now here's one thing also which is interesting that you should check, right, before we go even further, right? Let's check here. Cos and cos, when they multiply, they give you cos squared x, right? It's the same as saying x times x, right? It gives you what? X squared. So here we have cos squared x, right, multiplied by 2 sine x, right? That's how it works. Still divided by the same cos 36 degrees multiplied by what? Sine x, right? Nothing has changed there, right? So let me rub here at the top because we are done with it. So as we move forward here from this instance, right, we check now. Negative cos 36, there's cos 36, there's cos 36. That's a common fact, right? There's a sign, there's a sign, right? That's a common fact. So that means our common factor here that we can remove, right, is what? Cos 36 degrees multiplied by what? Sine x, right? If we remove cos 36 times sine 36, what are we left with? Negative 1 in this instance, right? If we remove everything here, we are left with what? Negative 1, right? Plus, right? Cos 36 and sine x are out, right? Cos 36 has been removed, sine x has been removed. So you're left with what? Cos squared x times 2. Or you can write it better by saying 2 cos squared x, right? Close the brackets. All over what? We still haven't forgotten our what? Cos 36 degrees multiplied by what? Sine x, right? Allow me to rub this. Allow me to remove this because it's no longer in use now. We've already passed that point, right? So I think now you can see it more clearly, right? You can see that after removing your common fact, there's something that we can cancel. There's something that we can use. There's something that we can remove, right? So let's check here, right? Let's check. What do we have here now? Cos 36 times sine x, cos 36 times sine x, right? So that means this cancels what? This, right? So we're left with what? 2 cos squared x, right? Minus 1, right? And we know if you go and check your formula sheet at the back of any question paper of paper 2 of maths, right, it shows you that cos 2x can be changed into a variety of ways, 3 actually, right, which is cos squared x minus x, 2 cos squared x minus 1, 1 minus 2 sin squared x, right? But here we've been given what at the end? 2 cos squared x minus 1. This is the same as cos 2x. So that means we can reverse it and say what? Cos 2x. And by doing that, you proved that the left hand side is equals to what? The right hand side, right? Yeah, so that's how you do it every single time. And here's another good tip, right? Every single time when you encounter a question where there's fractions, right, just know that the first thing you do, if it's divided or it's having, like I said before, right, if it's in this format initially where there's a sign in the middle, right, you first find the LCD, right? And then after finding the LCD, right, your main goal at the end is to find something which is going to help you to divide at the end, right? Because if you noticed, we divided or we cancelled, right? So that means at the top here, we were fighting by all means to get something which is the same as what at the bottom, right? So that they can cancel, right? And as they cancel, we are left with what we needed, right? So that's my advice to you. Just know that your main target, if you have fractions, is that at the end, you're supposed to produce something which is the same as the denominator, right? At the top, you see? So yeah, thank you guys for watching, and make sure you subscribe to my channel if you want more videos like this, or you want me to tackle other questions. Just leave a comment or email me. I'll leave the email on my description. And thank you guys. Sharp.